Now we will solve this numerical problem. Look, in this question we have to find the current through the 5 ohm resistance using Norton's theorem. Okay, so the 5 ohm resistance is the load resistance, that is RL. Okay, this is RL and this is the terminal denoted A and B. Okay, so in step number 1, look, the step number 1, we have to remove the resistance from terminal and make it short circuit. Okay, so this is our step number 1. Now we will replace this terminal, okay, and make it short circuit. Okay, making after make it as a short circuit, the circuit look like this. Okay, so we have completed the step number 1, and in step number 2, look, we have to draw the circuit to find ISC. Here the ISC means the short circuit current, okay, as viewed back by the source. Suppose this is the short circuit current ISC, okay, and we have to find this current. Look, as this 2 terminal is short circuited, that means this 10 ohm resistance also short circuited. Okay, so we can neglect this 10 ohm resistance because the current would not flow through this path, okay, as this is already sorted by this. So as we know that this 10 ohm resistance is short circuited by this path, so we neglected this 10 ohm resistance. Now the circuit look like this. So now we will find this current I, okay, as viewed back by the source. This term viewed back by source means we will consider only this we will consider our measurement considering this source. Okay, so first of all we will measure the total resistance, okay, as considering this voltage source first. Okay, so this is our voltage source, 20 volt. Okay, and after that this 4 ohm resistance. After this it is split it into 2 part. One is this, one is this. Suppose this is the 8 ohm resistance. So here the resistance is 4. So now we'll calculate the resistance. Here resistance is 4 plus 8 and 4 is parallel. 8 plus 4, 12. Okay. Okay, this is our equivalent resistance. Now we will find current using Ohm's law. V equals to IR. We know that. So I would be V by R. Here V is 20 volt. Here I is in this direction. I, suppose this is I. So V is 20 volt. 20 divided by, we'll simplify this here, 12 plus 8, 20 by 3. Okay, so 20 by 3. So answer would be 3 ampere. So now we have find the current I. Here the I, okay, and now we have to calculate the short circuit current, okay, ISC. Now look, the current I is split into 2 parts. Here is one part and in there is one part. Now we have to calculate this current ISC. Look, the current ISC means the current across this 8 ohm resistance. Okay, so now we have to find the current across this branch, ISC. It would be I into the opposite resistance, that is 4 by sum of two resistance, 4 plus 8. Okay, so here I is the current, that is 3 ampere. Okay, 3 into 4 by 4 plus 8, that is 12. So this is our short circuit current, ISC, or you can say the Norton's current, IN. You can also say IN. Okay, now in step number 2 we will find the Rn, and in this case we have to replace the source by their internal resistance. Okay, or by the if the voltage source is present, then it would become short circuit, and if suppose there is a current source present, then it would become open circuit. So this is the circuit after the conversion. So now we will find Rn, that means the Norton's equivalent resistance. So in this case, first of all we will consider these two terminal, that is A and B. Suppose this is two terminal A and B, and this 10 ohm resistance is connected in this way. So, okay, suppose this is the 10 ohm resistance. Now look, in one end 8 ohm resistance is connected, this is 8. After that it is split into two part, one is this and one is this, split it into two part. Okay, then this is combined together. So now the circuit look like this in simple form. Now we will calculate the Rn, that means the equivalent resistance. Here 4 and 4 is in parallel combination, so the total resistance in this path would be 4 parallel 4 plus 8. Okay, this is 10, and this 10 and 10 is in parallel, 10 parallel 10, 5 ohm. So this is our Norton's equivalent resistance. So now we have completed the step number 3 to find the Norton's equivalent resistance Rn. Now we will check for step number 4. Now look, in step number 4 we have to draw the Norton's equivalent circuit, and we have to find the current through the resistance, that is the RL. Okay, using current divider rule also you can find this. Now the circuit look like this. Okay, so here this is the IN, or you can say ISC, short circuit current, that is 1 ampere, and this is the Norton's equivalent resistance Rn, and this is the load resistance 5 ohm. Okay, across two terminal A and B, and we have to find the current across this. Okay, suppose this is I. Now look, in this case we will apply current divider rule again to find the load current. Okay, so here the source current is IN, so I would be IN into opposite resistance, that is Rn, divided by Rn plus RL. Here IN means, here IN equals to 1 ampere and Rn is equals to 5 ohm, and RL is also 5, so 5 plus 5 10, 5 by 10, so it would be 0.5 ampere. So you can say easily that the current across this load resistance 5 ohm is 0.5 ampere, I hope you understand this process. If you're new here, then please subscribe our channel and hit the bell icon.